Okay, so before we get started with too much into radicals, there's just some information that we need to review, okay? Radical expressions are any expression that include the radical sign. So it could be just one numeral that's within a radicand. It could be a binomial within a radicand. It could include a coefficient out front, or it could be a radical to different indexes. Okay. We talked during our lessons on exponents about the relationship between the exponent and the radical form, the exponential form and the radical form. So if we had a variable or a numeral that had a fraction that was its exponent, then the denominator of the fraction stated the index of the radical, and the numerator of the fraction told to what power. So for example, if we had x to the power of 7 halves, then what we had was the square root of x raised to the 7th power. Okay. Another example here is if we have the binomial 3x plus 2 to the power of 5/4, then what we have is 3x plus 2 within a radical sign to the index 4 raised to the 5th power. Okay. Finally, if we have a number like 32 to the 9/3, then we have 32, the cubed root of 32 raised then to the 9th power. Okay. Now, additionally, when we're looking at the powers of exponents, there are perfect nth powers, okay? N being whatever our exponent is. So if our index, if our exponent is 2, then we have a perfect square, okay? Now, any perfect squares could be x squared, x to the 4th, x to the 6th, x to the 8th. They're all multiples of 2 when we're looking at perfect squares. If we're looking at cubes, okay, perfect cubes, x to the 3rd, x to the 6th, x to the 9th, x to the 12th, these are all multiples of 3, okay? And finally, perfect fourth powers would be x to the 4th, x to the 8th, x to the 12th, x to the 16th, and obviously all these go on and on. So these are multiples of 4. All right, so when we're looking at simplifying, it's important to remember these perfect nth powers. Okay, all right, finally, last little bit here, like radicals. If we're talking about like radicals, what we're talking about are radicals that have the same radicand right here inside of the radical sign and the same index right here. Okay, so if we talk about like radicals, we're talking about radicals that have the same radicand and have the same index. Okay, so you might want to refer back to this information later as you're going through operations with radicals and simplifying radicals.